All right, in this video, we're going to be talking about section 2.5, part 1. We're going to break this into two parts. And there's not going to be a whole lot new in this section. It's still basically going to be finding the zeros of polynomial functions. It's just that this time we're going to have possibly some answers that are imaginary answers. But we'll get to that soon enough. So here's a little warm up. This is basically what we've been doing, and you should be pretty good at this point. Find all the zeros of this function and then write the answer as a product of linear factors. So I'm going to use my rational zero test and start breaking this down and finding my zeros, assuming I have some. So I'm going to look at P over Q. Factors of P are 1 and 2, and the factors of 1 are 1. So this just becomes positive or negative 1 or 2. So we've only got 4 possible zeros here. I am going to probably do stacked synthetic division, and I'm noticing I'm missing a term. So I've got my 1, I've got to throw in a 0, a negative 3, and a 2. I'm going to set up my stacked synthetic division, and we'll start with 1. Bring down the 1, multiply, I get 1 and add. 1 and add, I get negative 2, and multiply, and I get 0. So right away we found one of our zeros, and we found the factor that goes with it. So we know that one of my zeros is 1, and we know that we can rewrite P of x as a product of factors, and what we know so far is that x minus 1 is one of those factors. Now, the other factor that goes with it is not linear, but we do have this piece right here, which we know is quadratic. And so we are going to just take that and get out of synthetic division. X squared plus x minus 2. All right, so product of linear factors. This is not linear, so now I'm going to try to factor this by hand. And it looks like it will factor 2 times 1 and a positive 2 and a negative 1. So it looks like product of linear factors, x minus 1 is happening twice. So if you want, you could just write it like this, or you could write it all out. It does not really matter. But there are my product of linear factors. Find all my zeros. Looks like we've got 1. 1 happens again. I'm not going to write it again. And x equals negative 2. If I was graphing this, of course, I would pay attention to the multiplicity issue here of the 0 at 1. All right. But that's all that I've asked you to do on this one, so we're done. All right. So the fundamental theorem of algebra is kind of a huge letdown. If you name something the fundamental theorem of some big topic, man, that better be a pretty exciting theorem. Think of, some well-known Pythagorean theorems and stuff like that. This one is actually pretty lame. It just says the following. A polynomial of degree n has exactly n complex zeros. So in other words, any zero, whether it's real or imaginary, there will be n of them. Provided that the zero with a multiplicity of k. In other words, if you've got the zero that happens multiple times, we would count it k times. So long story short, basically says you're going to have n zeros as long as you count repeats and imaginary answers. All right. So that means anytime I look at one of these polynomials, we have a degree of 3 on this example 1. I know I'm going to have 3 zeros. So let's find them. Find all the zeros of the function and then write it as a product of linear factors. So just like the problem we just did. All right, P over Q. We've got factors of 6, positive, negative 1, 2, 3, and 6 over positive, negative 1, and 5. For a total list of 1, 1/5, 2, 2/5, 3, 3/5 and 6 and 6/5. All right, hopefully we'll find some pretty quickly. I am going to do stack synthetic division again. I'll do it over here. 5, -9, 28, and 6. Okay, here we go. I'm going to plug in 1. Bring down the 5, multiply, I get -4, multiply, I get 24. Obviously does not work. I will stop, move on. Bring down the 5. -5 makes -14, makes +14, makes 30 something. Not going to work to get back to 6. Let's try 2. 2 times 5 is 10. That makes a 1. 2 makes 30. And that makes 60. That does not work. Let's try -2. -2 makes -19. Makes +30 something. 38. Clearly not getting down to 6. All right. I'm not having a lot of luck with my whole numbers, but I'm going to keep at it, see if we get there. Bring down the 5. I get 15. That makes 6. 3 and 6 makes 18. Let's see. I'm just going to check something real quick. I feel like I guess we're good. 18 is going to make, that's not going to work either. None of these whole numbers really seem to be working, so I'm feeling maybe they need to try a fraction. So let's throw a fraction out and see what happens here. I'm going to try 1/5. 1/5 of 5 is 1. I plug in the 1, -9, and 1 makes -8. Suddenly, when I multiply, I'm going to get a fraction, and it's going to get worse and worse and worse. I don't think 1/5 is going to work out. I'll try -1/5. I plug it in. I get -1 makes -10. That's more promising because I can divide that by 5. So I get +2. +2 and 28 makes 30. 1/5 of 30 is 6, and it's -6, and I get 0. And I have my answer. So what have I learned? I have learned that one of my zeros is x equals -1/5. I have also learned that my factors are, I guess we'll say this for now, we might revisit it, x plus 1/5 times, looks like 5x squared minus 10x plus 30 equals f of x. So I'm now going to factor this or solve it some other way. I can definitely pull a 5 out of this, so I'm going to write f of x over here. I don't know why I did it over there. I'm going to pull the 5 out. I've got the x plus 1/5, and that's going to give me x squared minus 2x plus 3. And looking for factors of 3 that add to be 2, that does not seem possible. So as I go to find the rest of my zeros, I'm not going to be able to factor this one. So I'm going to use completing the square. So I'm going to ask the question, when does this equal 0? I'm going to move the 3 over to the other side. I could just slide it. I'm just going to move it over, make it -3. I'm going to factor, or I'm going to complete the square. Half of -2 is -1, squared is +1. I'm going to add 1 on the left side, and then I'm going to balance it by adding 1 on the right side. This now factors equals -2. Need a little room here. And right away I can see why I was having such a hard time finding zeros. That's because as I keep going here, I quickly see that I get an imaginary answer. So I move the 1 over, I get 1 plus or minus I root 2. So that's 2 more zeros. That's 2 more zeros to go along with my first one, and I have 3 in total. All right, there are my zeros. All right, the next piece is it wants us to write it as a product of linear factors, of which I've started working on that already. So the issue I have here is writing linear factors is going to be a little challenging because of these imaginary answers. But that doesn't mean we can't do it. So I'm going to keep working on these factors. Right now, I have factored this into, let's give myself a little more room. I've multiplied or factored into f of x equals 5 times x plus 1/5. And now I need to figure out how to write these zeros as factors. So let's just think about how we normally do this. Normally, if I know something is a zero, like for example, 1/5, right? A minute ago, I found out that negative 1/5 was a zero. So what factor does that create? Well, what I'm doing is I'm basically working backwards. I have found that x equals negative 1/5 is a zero. And so if I add the 1/5 to the other side, I get x plus 1/5 equals 0. X plus 1/5, we're saying, is one of my factors. Okay? So if we just follow that exact same pattern, I also know that there's a 0 of x equals 1 plus I root 2, and there's a 0 of x equals 1 minus I root 2. If I solve those individually for make them equal to 0, so I subtract 1 and I subtract I root 2, it now equals 0. This becomes my factor. So one of my linear factors is x minus 1 minus I root 2. And the other one, if I move these both over, I get x minus 1 plus I root 2. And there is my product of linear factors. Now, often what you're going to see is a question where it's going to say, write it with integer coefficients. And you'll notice I've got this 1/5 hanging out here. But notice this 5 I factored out earlier. Notice if I plug in that 5, I get 5x plus 1. So I'm not saying this is a requirement, but this would be the better answer to give so that I don't have any fractions. Okay? So anytime you think about it, right? If I get negative 1/5 as a 0, like we did over here, that could mean the factor is x plus 1/5, but it could also mean the factor is 5x plus 1. Because if I set that equal to 0, I subtract 1 and divide by 5, and I get negative 1/5. So both a factor of x plus a fifth and a factor of 5x plus 1 both lead to the same 0. So oftentimes when you get that fraction answer, it's going to end up probably simplifying out that you can make it into one without fractions. All right, but maybe that's a little advanced for where we're at right now. All right, long story short, either of these would work. All right, let's move on. Part B, go ahead and try this on your own. Please pause the video and check back in and see how you did. All right, I'm going to do my rational zero test. I'm going to find the factors of 16. 1, 2, 4, 6, 8, and 16, all over 1. And so really those are my possible zeros. 4, 3, 2, 1, 0. No missing terms. Ooh, nothing I can factor out either. I should really be checking that, but I keep forgetting. All right, so let's play our game. I'm going to do stacked again. And here we go. Bring down the 1, multiply, add, multiply, add. Let's see, 1 times 5 is 5. That makes negative 11 times obviously does not work. I'm going to try negative 1. Makes negative 1 and negative 5. Makes positive 5 and 8 is 13. Negative 13 and 16 is negative 29. Clearly not heading for a cancellation. All right. 2 makes negative 2, makes negative 4, makes 4, makes 8, makes negative 8, makes negative 16, makes 0. All right. So I found one of my zeros. But I've gone from a quartic to a cubic. So I'm not ready to give up on synthetic division yet. Come on, erase. Thank you. So I'm going to keep going. I'm going to continue to use 2 as a possibility because it could work again. But again, this time in stacked, we're not going to pay attention to the original or this or this. Our work is now happening right here. So bring down that 1, makes 0. 0 makes 4. 2 times 4 is 8, makes 0. Sure enough, the 2 worked again. And now I'm left with a quadratic. So I know that h of x factors into x minus 2 times x minus, that's weird, x minus 2 and x squared plus 4. So if I want to find the zeros, I now set the function equal to 0 and I factor. Well, x squared plus 4 won't factor. So I'm now going to sort of just switch my gears a little bit, and I would set each factor equal to 0. Well, I don't need to do the x minus 2's because that's how I got them. I already know the zeros. Let's just go write the answer down here. So I know the zeros are x equals 2 with a multiplicity of 2. And I know that whenever x squared plus 4 equals 0, because again, what am I doing? I'm factoring and setting each factor equal to 0 because that's how the game is played. So I solve, I get x equals 2. I solve, I get x equals 2. I solve, I get x squared equals negative 4, which is x equals positive or negative I and 2. So it's going to be 2i. So my zeros are x equals 2, x equals 2i, x equals negative 2i. And now for the product of linear factors. So I have most of my answer, but I do not have my full answer yet because this one is quadratic. So I need to simply do exactly what I did right here. I need to move the 2 over, set it equals 0, I get the factor. Move the 2 over, I get the factor. I need to move the positive 2i and the negative 2i over. So moving those over gives me x minus 2i equals 0. And if I move the negative one, I get x plus 2i equals 0. So that means my product of linear factors is the following. X minus 2, x minus 2, and then x plus 2i, x minus 2i. Set all those equal to 0, and you would get the zeros right here. All right, I'm hoping you're understanding this. If you're not, please rewatch and or come talk with me. All right, I think this is, we got one hidden way at the bottom here. Example number 2. Find all the x values for which x cubed equals 8. Well, hopefully we look at this and we automatically know 2, right? The answer is 2. But we just learned that the fundamental theorem of algebra tells me that something with x cubed actually has three answers. So what are we going to do to solve this? Well, if we move the 8 over, I get x cubed minus 8 equals 0. If you remember the rule that you briefly learned in Algebra 2, there's a shortcut here for the difference of two cubes. So I could answer this a little bit faster than maybe some of you because I know that this is going to factor because I know the rule. The rule tells me if I have a cubed minus b cubed, then it factors into the cube root of the first term minus the cube root of the third term times that first a squared plus ab plus b squared. So it's very similar to, like, if you look at this part of it, it's very similar to what you get when you square a binomial. The only difference is it's not doubled in the middle, right? It's not 2ab, it's just regular ab. All right, so I'm not giving you this because I expect you to memorize it, but what I want you to notice is we can get this through the skills we have learned, including synthetic division. So this is a problem that we can run our rational zero test on. So I can do my factors of 8, and then I can start checking them. However, didn't we all just agree a second ago that 2 is a 0? Like, we already know that 2 cubed equals 8. So I already know that that works. What I don't know, if I don't remember this part, is that I don't know what the other factor is. So what I'm going to do is I'm still going to do my synthetic division. 1, 0, 0, negative 8, 3, 2, 1, none. And instead of guessing all the numbers, I already know 2 is going to work. So I bring down the 1, I get 2, I get 4, I get 8, I get 0. So that confirms that 2 is a 0, and I also now know the rest of it. So this is going to factor into x minus 2 times x squared plus 2x plus 4, which is exactly what this statement up here is going to give us. The a is simply x. The b is the cube root of 8, which is 2. So I have x squared plus 2x plus b squared, which is 4. Okay. This result here, we can quickly see, does not factor. Factors of 4 do not add to be 2. And so this doesn't factor. So I'm going to use completing the square. So focusing on this part, I need to find out when that factor equals 0. So I'm going to move the 4 over instead of slide it, but you can slide it over if you want. Half of 2 is 1, and I'm going to square it and add 1 and add 1. This left side now factors because that's what I told it to do. And I see that I'm getting an imaginary answer because I take the square root and I get an answer of x equals negative 1 plus or minus I root 3. So find all the values such that when we cube it, you're going to equal 8. Those values, of which there are 3 of them, are these two plus the one we originally knew. These are my zeros. All right, let's see what the last question is. I don't know why I left so much room. Probably an accident. All right, find all the zeros of this function given that we know one of the zeros is 3 minus I. So I'm giving you one of the zeros, and we just need to find 2 more. However, I think if you think about it, that we actually have been given 2 zeros, not 1. Because the only way I would have an answer of I, which is a square root, is if I took a square root. And if I took a square root to get a negative I, doesn't that mean we would also have his partner plus I somewhere around, right? If you back up to any of the problems we just did, when we took the square root to get an I in this answer, we had a positive and negative. So whoever gave us this answer actually left off a very crucial piece of information, that my zeros, I already know two of the three. One of them is 3 minus I. One of them is 3 plus I. So now the question becomes, how do I find the last zero? And the answer will be through multiplication and division. So what does this tell us? What factor actually created these two zeros? And there's the easy way to do this and there's the hard way. I'll start to show you the hard way and maybe finish it, but there is a much better way. So if I want to figure out what factors these came from, then I just need to set this equal to 0. So I'm going to subtract 3 and add I. I get x minus 3 plus I equals 0. That makes this one of my factors. And if I do the same over here, I'm going to x minus 3 minus I. That's one of my factors. So I know that f of x is equal to those two things multiplied together, and some other unknown one we haven't figured out. So if I multiply these together, they're two trinomials essentially, so I got to do a three-way distribution. X times x is x squared minus 3x minus xi. Negative 3 times x is negative 3x plus 9 plus 3. I lost track of what I was doing. I. And finally, I would multiply by I, and so I'd get positive xi. I would get negative 3i, and I'd get minus I squared. All right, if we look at this carefully, I thought I saw some things that seemed familiar. Xi and negative xi, negative 3i and positive 3i. And so an I squared is negative 1, so this is just plus 1 over here. So it looks like I've got x squared minus 6x, x squared minus 6x plus 9, and then minus the negative, or plus 1, so plus 10. So when I multiplied those two factors together, I got this. I still need to figure out his friend. All right, before we figure out the friend, let's do that a much easier way. And here's what I'm thinking about. I'm going to go back and let's review this completing the square that I did. So to complete the square, starting at this line right here, my little clicker's not working. I moved the 4 over, and I completed the square and found a 1 and a 1, and that got me this. And then I took a square root, and I moved the 1 over, and I got this answer. Well, that looks really close to what I have right here. I know, I'll back up a little bit. I know that x equals 3 minus I and 3 plus I are zeros. So I'm going to kind of do what I did right here, but I'm thinking about reverse completing the square. So I'm going to move just the 3 over. And I don't want that stinking I there, and so the best way to get rid of an I is if I can square it, I should square it, since I can do it on both sides. So I get x minus 3 quantity squared on this side, and over here I get I squared, which is just negative 1. If I FOIL this out using our quick shortcut, that's just x squared minus 6x plus 9 equals negative 1. If I move the 1 over now, x squared minus 6x plus 10 equals 0. There is my factor that we found a much harder way. All right, so this is just noticing that this looks like the answer to completing the square, and so I start to unbuild it. Move just the 3, leave the I over there, because now I can square both sides and get rid of the I altogether. Okay, that was a lot of work, and we're not done with the problem. So I know that x squared minus 6x plus 10 is is actually 2 of my zeros. And more importantly, is a factor. So if I want to find the other factor, I just need to divide. Except we're not going to be able to do synthetic division because we're not dividing by a linear term. So 2x cubed minus 13x squared plus 26x minus 10 divided by x squared minus 6x plus 10. So this would be a 2x, giving me 2x cubed minus 12x squared plus 20x. I now need to subtract all of this, so I need to distribute that negative, which cancels out, which turns into negative x squared, which turns into 6x minus 10. And so I take a look, and I need to multiply by negative 1, and that'll turn that into negative x squared, positive 6x, minus 10. And I can see that now when I subtract these, I get 0. So what other factor goes with this? 2x minus 1. Because 2x minus 1 times x squared minus 10x, or whatever that says, equals that. All right. I think that about does it. We will check back in and do part 2 in the next video.